All right, so I'm going to be here today and talking to you about flaky tests and what you can do about them. So my name is Rob. I'm RJ Paskin on the internet, on Twitter and GitHub and all those things. And I am a developer at Createk. We're an agency based in Ancoats. Hi, Will. So let's start off, like with all good talks, with a definition. What is a flaky test? It's kind of one of those things, it's a bit like obscenity, you know when you see it. But generally, you think of a flaky test being some test that fails intermittently. Either it fails on certain days of the month or certain times of the day. There's tests that fail sometimes when they're run in a certain order. So I'd like to step back for a bit and ask the question, why do we have tests in the first place? Specifically, why do we have an automated test suite? Hopefully, if you're all Ruby developers, you'll have or work on apps that have automated test suites that are run on some CI server somewhere, or at least on your own machine. And there's probably several reasons why you have it, but I think the main one is that it gives you confidence when you're making changes to your code, whether or not that's having new features, making refactorings, or even taking out dead code that you think isn't used anymore. It's nice to know that you've got a good, strong, stable test suite that's got your back and will flag up if you have any problems. Now, the problem with flaky tests is they destroy that confidence, because if you can no longer say that your test suite is stable and consistently gives you good results, you don't know whether you have a flaky test that flakes on the side of passing when it's actually broken, or is broken and flakes on the side of passing. So I guess probably what you all want to know is, how do we deal with flaky tests? So by step 0, after you've identified your flaky tests, maybe you've been through just from word of mouth, fellow developers, you can do sort of more thorough analysis. What I've done is looked at builds that have failed and that then succeeded when they retried, and looked at those tests that actually failed. But after that, step 0, skip that test. Pretty radical, I know, but skip it. Because to bastardize the phrase, it is worse to have a flaky test than no test at all. Because as I mentioned, the flaky tests can give you false negatives or even false positives. They create false hope, and it's the hope that kills you. So skip it, but equally as important as skipping it, so this is how you skip it in RSpec. You can just add a skip command. You can add skip metadata as well, but you can do this in Minitest or Jasmine or any test suite really. But step 2 is to make a note somewhere, either in your issue tracker, your bug tracker, on your Kanban board or whatever, to go back and fix those flaky tests. Because otherwise the danger is that they stay skipped forever, and there's a good chance that you'll come in and break something, and then you've kind of defeated the whole point of having an automated test suite, which is to catch regressions. So you can either sort of tag them with something that's easily graphable, or make a note of all the file paths. Generally, you probably want something easily graphable because file paths can change. So, onto causes of flaky tests. So, at Createk, we work on a very large and very legacy application that I've been on a bit of a crusade recently to get rid of some particularly persistent flaky tests. And so, I feel like I probably should address the elephant in the room first, which is capybara. And I did find that quite a lot of tests were due to capybara, or in spite of capybara, or occurred in capybara tests, in being charitable. But actually I found that a lot more of the tests failed due to randomness. So that can either be randomness in values that are going in, or randomness in the order in which we run tests. So one particular source of randomness, which is kind of by design, I found was the faker gem. There are other gems available, but I found that the faker gem is generally the most popular. And so the Flaky gem, if you've not used it before, gives you a bunch of methods to create realistic looking test data. So here's a factory, or maybe even a fixture that you've probably seen or thought of many times in your working lives if you're a developer. So we've got a user factory that defines a name, and we just pluck out a first name from Faker. We take that value, run with it. We don't really care what it is. So here we've got a reasonably standard capybara feature spec. So we're creating two users. This is using the capybara syntax, the factory girl syntax, but again, syntax here is not important. So creating two users, going to the user's path, making sure that both those users show up on the path. We're then filling in some search field with the first user's name. We're performing that search, and then we're making an assertion that the first user, the one that we searched for, has turned up, but the second user hasn't. So we commit this one, run the test locally. Yeah, looks good, looks good. So we send it off in its merry way, and time passes. It's fine, it's fine, it's fine, it's fine. Nothing to see here. Until one day, it's an F. It's the worst letter in the alphabet, especially in red. So we see here that we've got an error on the last expectation, which is that we're expecting user 2 not to appear, and this is failing. And so you can see here, this is capybara saying that it's expecting some text to be not there, but it is there. So the more eagle-minded amongst you might have noticed that we've got a bit of repetition here. And to understand why that is, need to talk about odds. Okay, so I had a look at the Flaky gem. I wanted to see exactly where does these first names come from, and it turns out that it's just a big YAML file. It's just a list of names that they've deemed that they wanted, and in the particular version of the gem I looked at, it's just over 3,000. So that means, to my naive mathematical mind, that there's probably about a 1 in 3,000 chance that you're going to get a mismatch, probably slightly higher because of things like the birthday paradox. I don't know, I'm not a mathematician. But there's a small chance that's going to flake out. However, there are other factories or Flaky randomness generators in Faker. One of those quite popular ones is countries. And countries, they don't change that often. At the moment, there's 245. And so if you're generating a random country, and one test that I fixed recently was creating a country, assigning that country to something, and then checking the country changed. And so there's 1 in 245 chance that actually, if you assign Paraguay and get Paraguay back, you've got no way of knowing whether or not it's actually changed. And a last one, which is a particularly favourite from a developer whose project we inherited, like the more esoteric Faker ones, and there's one that gives you Lord of the Rings characters. Now, unfortunately, despite the fact it's Lord of the Rings as well, it only gives you 30 characters. Obviously they didn't read the Silmarillion or anything. But yeah, so this one flakes out majorly. So, what's the fix? Well, in this case, we can consider this test to be an instance of a mystery guest. So a mystery guest is some piece of information that is critical for how the test functions that comes from somewhere else in your test suite. You don't really know where, it just comes from somewhere. And so what we do here instead is we put it front and center in the test and we hard code it. So we can now be sure that these names will never overlap. Notice they don't have any overlapping characters as well, because that's another problem you can find. And so we've maybe lost things that we might have had sort of surprise discoveries where, if somebody had a really long name, it might have broken our test. But the flip side is we now have, hopefully, a rock solid, stable test. Okay, the second source, well, not really source of randomness, but something that is very much prone to breakage with randomness is changing global state. Now, hopefully most of your tests are self-contained. They set up and they tear down, and they don't leave any sort of rubbish or change things in their wake. But of course, that's the ideal world. Doesn't always happen that way. So here we've got a user class. It's an active record, and it's got a before save hook that creates a bunch of records for that user, like a photo and some likes or I don't know, something. The important thing is it creates a load of stuff that we don't want, because we've done some analysis and we found that this class majorly slows down our test suite. So we hit the Googles and we have a look and see, okay, how do I skip the callback to an active record? Wait, no Rails docs came up. This is unrealistic, of course. Stack Overflow will come up, but it probably would lead you here. So we have a look and it says, skip a previously set callback. Sounds like what we want. And then if, unless, blah, 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 who cares? That looks good. So stick it in the test. And yay, now our test suite runs a lot quicker. So it's great. Run tests. Yeah, it's all good. Push up to CI. Off it goes. Building, it's fine. Up to here, perfectly fine. Until, of course, one day in the not too distant future, it's another failure. So in this time, we have a look at the line number, because we're like, well, I think I made my change on like line 130, and this is like line 10, and it's like, user does the thing, and I don't know. But just to be sure, we pick up the seed that it used, and we run the tests again, and we can see these ones fine, the ones that we added, or sped up I should say, but this one is failing. So again, just to make sure, change the seed around, runs fine. But you'll notice that the seed, which dictates the order in which these things are run, has put this one up here, and this one down here. So I think we've probably got some order dependence in here. So we have a look at our file, and we can see right down the bottom, here's where we added our skip callback. So we scroll up, scroll, until we get to line 10. And we can see here, we've got some test. There's actually testing the before save callback. So we're new up a user, saving that user, and expecting that user to have done the thing. So it turns out that skip callback is a badly named method. It should actually be called delete callback, because that's what it does. The big clue in retrospect is the fact that you're calling on a class, and generally class methods that are doing something that changes state are normally a bad idea. And so it happens that if this thing runs before this thing, the callback is wiped, and so this assertion is always going to fail. So how do we skip it? Well, how do we fix it? So in the short term, I'd probably say stub it. So this is the rspec mocks syntax. So we take the user, we allow them to do the thing, and we just return true. So we don't do all that heavy lifting. Probably longer term, you may want to look at separating out the sort of the creation of stuff from the user model. So the user model stays light, and you've maybe got some service or some auxiliary object that creates all the stuff for you in only the cases where you want it to. Okay. As an aside, something that I discovered that is life-changing in no small way is rspec bisect. So if you do find that you have a failing test run and you suspect it to be order dependent, what you can do is call rspec with the bisect seed, bisect flag, give it the seed where it failed and the list of files or the directory like you do. rspec will then run your tests, find out if it is indeed order dependent. It will then take the failing test or failing tests and run them repeatedly with a set of increasingly smaller number of tests until it can find the minimal reproducible test run that fails. So generally you can find, normally quite quickly, depending on how many files you run, exactly which file is causing the problem. and which causes the other file to break. So it's amazing. You just set it running, go for lunch, come back, it's done your job for you. So this is the future right here. Okay, the third subject I want to talk about is something that I think is dear in all of our hearts, date times and time zones. I could probably fill a whole talk, maybe several talks, about the interesting specifics about dates and time zones. But I want to focus on one, which is sort of Rails specific, but I found it was quite interesting. So we've got an app here where you can make appointments for some date in the future, and we have the requirement that a month before your appointment you get emailed about that appointment, just to remind you that, hey, still going on. Okay, so we can bash out an implementation quite quickly. We just say, a month from now, loop over all the appointments, send a reminder, and the test is hopefully reasonably straightforward as well. We create an appointment with a date a month ago, and then we run it for today, and we expect the reminder count to change by 1. Yeah, it's fine. However, a few months later, depending on when you write it or not, another failure. So again, we're expecting the count to go up by 1, but it hasn't changed at all. So it just hasn't sent them. Okay, so this can happen on certain dates. And so I think it's worth stepping back for a moment and considering how Rails does data arithmetic, because it's really great or horrific, depending on the state of view, that Rails monkey patches the integer class. So we can say 1.month or 30.days. And this returns something called an active support duration, which kind of acts like an integer number of seconds, but it kind of knows some special things about itself. And so months, as hopefully we'll learn in primary school, don't always have 30 days, but for the purposes of duration, a month does, because if you've got to pick one, might as well pick 30. However, if we then say a month from now, this is not always the same as 30 days from now. So these things aren't actually synonyms. They do know that they represent a month or days. And so this is the case where we're tripping up. So if imagine we run this on New Year's Eve, great time for CR to fail as well, and we say a month ago, you'll see that we get back the 30th of November. And this is because the way that Rails works is it will try and find the next matching date, which in this case would be the 31st of November, but that doesn't exist, so it'll then round down. So then the problem then arises if we then try and go forward from that date, because if we go a month forward from the 30th of November, the 30th of December does exist. So unfortunately we can't round trip these values like the ease and simplicity of the syntax would suggest. So in fact you can find all of these dates. You can use the natty all year method that gives you a range that goes from 1st of January to the 31st of December. And we can loop over all of those dates and choose the ones where if we go back a month and go forward 2 months, we don't get the same date as going forward a month. And outfalls probably the usual suspects, a lot of dates in March, primarily because they follow February, July and December. And it turns out these are all months that are followed by months that have 30 days and then months that have 31 in this particular case. But I found other ones. Generally, these, there's about 7 dates tend to sort of crop up time and again. So the fix in this case, and the strategy we went for, was actually maybe slightly oblique, because this represented a ticket that my team had been working on and off. It come back to us 3 times in various iterations with various bugs. And so we decided in the end, actually, doing all this data arithmetic was kind of quite complicated. There was no real insight for the end user as to when actually things get done. And so we actually kind of took the easy way out a little bit and scrapped the tests and decided to change the implementation, which is always a great way to do things. And so we decided to set a static reminder date. So we calculate this once before you create the appointment. But we now have a column that we can now look at, we can query, we can show the users. And so we can even dependency inject in here, so we can run it, this reminder method for today, or we can pass in other dates if, say, for example, the scikit job or whatever that runs this falls over. I would say that I'm sure there is a way to fix this. I did spend some time trying to work out okay, is there a way in case it works in all cases? Fortunately, I don't think there is. In our case, we ended up just writing some special cases for these dates and just made a note that when the test suite runs on those days, it puts out a big yellow warning that says, yeah, it's not going to work, and shifts to a date that will work. And then we test those 5 cases separately when we know that the dates are going to be a bit wonky. So lastly, back to the elephant or the capybara in the room. And I think probably the main cause of capybara flakiness is waiting. Specifically, capybara not waiting long enough. And so a fair amount of capybara failures can be fixed by rearranging your syntax a little bit. So for example, here we're using the find method with an ID. Now this method will wait, but in this case, we're actually making kind of 2 assertions here, which is that there is an ID of user somewhere in the page, and that has the text flaky. So the way that this is written, this could succeed, but it might not have the actual text that we want, but capybara doesn't care, it's found what it wanted, so it's going to return something, and this could be not the text you want. So generally, the rule of thumb is to move everything into the assertion, if you can. So most of your capybara assertions become assertions on a page or some selector. So in this case, we use the has.css selector, and we can pass in text, and this will do a partial match by default. Another one that seems quite innocent in a way is doing assertions against the current path. And this again is something that probably works most of the time, but occasionally, particularly if your CI server is under heavy load and goes really, really slowly, and it can break. And so again, the solution here is to move everything into the assertion, and it so happens that they actually have a special matcher just for the current path, and this will wait within the allotted time to make sure that it actually passes. And so in thinking about this, I was actually intrigued one day to find out how does capybara actually does it? Because you kind of think well, it just waits, and it's kind of all a bit magical. But yeah, no, it turns out it's just a big loop basically for the sleep. So this is sort of the simplified version of the method that gets hit. So basically, record the now. The time is our start time. We go through all of these assertions, raise an error. So then we have a look and see basically has the difference between what is now and the start time exceeded our wait time, which is generally, I think it's default 2 seconds. Otherwise we sleep a bit and then we retry. So capybara is basically sitting there doing loads of these little loops for every assertion. Okay, another one, a problem that I found is that sometimes, although you've got things that all wait properly, often you're making assertions against some state in the database. And again, this test will probably work most of the time, but sometimes because we're not actually waiting for the form to submit, this could possibly fail. So again, the solution here is to add an extra assertion that something has changed on the page that represents the form swimming completely. So in this case, we're just saying like, just have a welcome message. And so again, to bastardize the phrase, if a user action doesn't change the page content, did it actually happen? Is this test failure or test flakiness actually masking the fact that we're doing something, but we're not actually reflecting it to the user? And so this flaky test has kind of revealed a problem in our implementation where maybe actually we shouldn't be making assertions against the database, but instead asserting that things are being shown to the user that could have only happened in this case because they got signed up. Okay, so in summary, beware of mystery guests. Try and bring state that your tests depend on into the test itself. Be very careful about mutating global state. And if you do have to, because sometimes you do, try and reset it. Specifically, I mean, that's where RSpec mocks is quite good because it automatically will do a teardown, and most mocking libraries do this for you, so you don't have to think about it. Use RSpec bisect to find order-dependent tests. It's amazing. It's that sort of bright, shiny AI future we all promised. Remember that not all months, days, time zones are the same, unfortunately. British summertime is a thing. Unfortunately, tests do fail British summertime. And it's always good to know when Capybara will wait and when it doesn't, what methods do, and sometimes you might need to add in some extra weighting. So here's my rallying call. Go forth and deflate your tests. Thank you.